This is lesson 4.2, Linear Inequalities and Systems. This is part 1. We're going to start with doing the warm-up. So if you haven't already done that, then pause the video and do the warm-up. You will need 2 different colored pencils for today's lesson. Okay, for the warm-up, you are supposed to graph the line y equals 3/2 x minus 8. So you're going to start at the y-intercept at -8. You're going to go up 3 and over 2. And you're going to graph that line. And so with a straight edge, you have this line, red. Okay, and then it says shade above the line. So I'm going to get one color and I'm going to shade above the line. Okay, so with an actual pencil on paper, this would be a little bit easier, but I'm going to shade above the line with my green. And then it says with a different color, shade below the line. And that's all we're doing for that one. The second part of it, it says graph the line y equals -3/4 x plus 5. So we start with 5. We're going to go down 3 and over 4 and graph the line. So like that, arrows on both ends. And then it says with one color we're going to shade above the line. So I'm going to do the green again for above and below the line. And so one way you can think about this is that think about your line as being the roof, and if the rain is coming down, where would the rain hit? It would hit above the roof. So think about where that rain is coming down. So if rain was coming down, it would come over here. Below the roof is where you're going to be sheltered, and so that's where my purple part is. So today we're going to be talking about graphing inequalities. And so it's similar to graphing equations. When we have an equation like y equals 2x plus 5, when we graph that line, all of the points on the line are solutions. All of those ordered pairs will make the equation true. And so that's what we're doing when we're graphing the line. We're finding all the solutions. Because with 2 variables, there's an infinite amount of solutions to that equation. With an inequality, we're also going to find all of the solutions. But because we talk about, instead of saying x is equal to, where there's only one thing it could be, if we say x is less than 2, there's infinite things it can be. So we actually have more solutions with an inequality, generally speaking. So it says to graph an inequality, there's some things to remember. When you have a greater than symbol or a less than symbol, you are going to use a dashed line. If you're going to have a greater than or equal to, or less than or equal to, you're going to do a solid line. If you are going to have the greater than, or greater than or equal to, you're going to shade above. So like we did on the warm-up, you're going to shade above where the rain would come down. And then if we're going to have less than or equal to, you're going to shade below. So we're going to be using all of those things to shade or to graph inequalities. And so I'll show you how to do that. But there is one little thing that gets confusing, and it's when you have a vertical line. So if you have a vertical line, how do you shade above and below that? So you'd still do the dashed and solid line depending on if you have greater than or equal to. But if you want to know like where to shade, so if this is say 5, the numbers that are over here like 6, 7, 8, those are greater than. The ones over on this side are less than. And so if you're shading greater than, you're going to shade to the right. If you're shading less than, you're going to shade to the left. So we're going to use that to graph inequalities. When we are graphing inequalities, like I mentioned, we're finding a lot of different solutions. And so we have an infinite number of points that could be solutions to an inequality. So if I say x is less than 2, we can come up with a lot of things that will satisfy that. So the first thing we're going to do is check to see if we have solutions. So here's my solution for number 7. And so, or that's my inequality. And I want to know, is 3, 2 a solution? Is -1, 4 a solution? So we're going to check to see if they are. And so the way you check that is by plugging in. So you're going to take x and y, and you're going to plug them in one at a time. So in place of x, I'm going to put 3. There's nowhere to put y, so all I have to do is decide, is 3 less than 2? That's false. So that is not a solution. Okay, now I'm going to do the other one. I'm going to take x and I'm going to put it right in there. So -1 is less than 2. That is a solution, so I'll circle that one. Go over to number 8. So I'm going to take, for y is less than 7, the only thing to plug in is the y. So I'm going to say 8 is less than or equal to 7. That's not true. Try the 9. well, not the 9, but the 1, put it in for y. 1 is less than or equal to 7. That is true. Okay, when I have two variables, it's going to work the same, except I'm going to put in for both of them. So in place of y, I'm going to put -2 minus and then x. Is that a true statement? So that's -5 is less than or equal to 6. That's true. So this is a solution. Trying the next one, I'm going to say y, which is 1, minus x, which is 4, is less than or equal to 6. So that's -3 is less than or equal to 6. That is also true. So both of those are solutions. Okay, pause the video and try number 10 and see what you can figure out about those being solutions or not. Okay, for the first one, we're going to plug in 4 times y, which is 4, minus 2 times x, which is -1. And so we're going to have 16. -2 times -1 is +2. And so I'm going to have 18 is greater than -3. That is true. That is a solution. The second one, I'm going to say 4 times x, which is 3, minus 2 times y, which is, 2 times x, which is 6, is greater than -3. So that's 12 minus 12 greater than -3. That's 0 is greater than -3. That is also true. That's also true. So that one is true too. So we have examples where we have one of the points being a solution, two of the points being a solution. There's a lot of other points that could be solutions for these inequalities. It could be possible that maybe I gave you an example where nothing's a solution. So being able to determine if you have a solution or not is important, because then when you get your graphs, you can decide if you did it right. Okay, for number 1 with graphing, actual graphing the inequalities, what you do is you notice, first of all, that it's an inequality. So this is going to be slightly different than if you graph an equation. But you're going to start out like it was an equation. So if you had y equals x plus 3, you would start out at the y-intercept. You're going to have a slope of 1, and so you're going to graph that line. But before you connect your dots, stop and ask yourself, do I have a solid or a dashed line? Because it's greater than and not greater than or equal to, we're going to be doing this with a dashed line. So you need to make sure that you pay attention to that, because you've got to have a dashed line. Now we're not done. That's not it, because where are my solutions? It says y is greater than, so I want all of the numbers that are greater than x plus 3. So all the ordered pairs. So the way you determine that is, if, remember back here, we said if it's greater than, you're going to shade above the line. So that's what I'm going to do. I'm going to shade above the line. So I'm going to get my pencil and I'm going to shade all of this area that's above the line. And that's my solution. So what it means is, if I get this ordered pair right there, so that ordered pair is -2, +5, that means that if I was to plug in for x and y into that inequality, 5 is greater than -2 plus 3, that's going to be a true statement because it's in that shaded region. If I was to pick something like 0, 0 and plug it in, 0 is greater than 0 plus 3, that is false, not true, and that's why it's not in the shaded region. So what you're doing here when you graph this is you're shading all of the area that has the solutions. And of course this goes on forever and ever. It's just that we're going to just graph it in what we have right there. But we're graphing all of the solutions. So the points that are on the line are not solutions because of the dashed line. If that was a solid line, then I would have solutions to that. So let's look at another example. Number 2. This one says y is greater than or equal to. So I know when I graph it, I'm going to have a solid line instead of a dashed line. And since it says greater than, I'm going to shade above the line. So let's graph it. We're going to start with a y-intercept. I'm going to go down 1 and over 3. I'm going to connect the dots with a solid line. So get your straight edge. And you're going to connect this, arrows on both ends. Greater than, I'm going to shade above. So think of that as being a roof. Where does the rain come down? It comes down above. So these are my solutions. All of these ordered pairs that are in there. So there's billions of points within that shaded region. And because the shading even goes out here, that would still be solution. So the way you can decide if that's true, you can pick a point, like that would be 0, 3, and I'm going to see if that's true. So instead of y, I'll put 3 greater than or equal to -1/3 times 0 plus 1 is 3 greater than or equal to 1. Yes, that's true. On the other hand, what if I pick this one? 0, -1. So I'm going to put negative 1 greater than or equal to negative 1 times 0 plus 1. Is negative 1 greater than or equal to positive 1? No. So I'm very confident that I'm doing this the right way. I shaded in the right area, shaded above the line. And so you don't have to do anything else for your solutions. The graph is the solution. So you just show the graph and make sure it's shaded. I'll be looking for dashed or solid lines, the shading, and that's it. Okay, number 3, go ahead and pause the video and try this one on your own. Okay, I have the line y is equal to negative 4x, and I did a solid line because it does say less than or equal to, and so I do the solid line, I don't do a dashed line. And it says y is less than, so I'm going to do below the line. And so the question is, where is below? So think about, if the rain is coming down, which side of that line are you going to be on? So below is going to be over here. So you're going to shade that in. Now when I'm on paper, I like to just completely color that in. And you want to go, up against the line. Looks a lot better on paper, but anyway, that's how you're going to do it. And so the shading is just showing all of the solutions. So on your paper, I want to be able to see clearly that the line is there. So make sure you make the line dark enough and make sure I can tell if it's a solid or dashed line. The shading, I don't want it so dark that I can't tell where the line is. I should be able to see where the line is and see that it's shaded, but don't get carried away. You can look at some of my examples on the answer key if you want to know how that should look. Okay, number 4. This one, you'll notice y is greater than negative 5. What kind of line is that? There's no x. So remember that when we graph something like that, we're going to go through the y-axis at negative 5. So I'm going to come down here, and because there's no equal sign there, it's greater than only, I'm going to do a dashed line. And then I have to decide, where do I shade? So the thing with inequalities is there has to be shading. If there's no shading, you have not done it. So y is greater than. So with a horizontal line, do you think that greater than would be up here, or would it be down there? Hopefully it's pretty obvious that you're going to be shading up here because it's greater than. And so greater than is going to be above. So again, with your paper, you want to make sure it's shaded, but I definitely need to see where the lines are. So make sure that that's very clear where that is. Okay, now we're going to turn it the other way around, and I'm going to give you the graph, and you're going to write the inequality. So what we're going to notice is we notice that it's a dashed line, so it's either going to be greater than or less than, no equal to. It's shaded above, so I know it's going to be greater than. So I know that when I get done with this, I'm going to have y is greater than something. Now the next part of it is we need to find the slope and the y-intercept. So I find the y-intercept is at negative 4. The slope is negative. I'm going to go down 2 and over 3. So negative 2/3 is the slope. So I'm going to write my inequality. Y is greater than negative 2/3 x minus 4. That's the inequality that represents this graph. Okay, this one is a horizontal line. We actually just graphed something like this. I know it's an inequality because of the shading. That's what gives it away. This is a solid line. It's shaded below. So that means I'm going to be doing less than or equal to. Less than because it's shaded below, equal to because it's a solid line. So when I go to write my inequality, I'm going to have y is less than or equal to something. I look at my y-intercept, it's at 5. My slope is 0 because all horizontal lines have a slope of 0. So when I go to write that inequality, I'm going to write y is less than or equal to 5. Because remember how you write an equation for a horizontal line? Same thing except for just an inequality. Okay, number 7, same thing. I know it's shaded below and it has a solid line. So again, I'm going to do less than or equal to. I can see that my y-intercept is at 1. My slope, find 2 points. I'm going to go up 3 over 4. So 3/4. So I'm going to say y is less than or equal to 3/4 x plus 1. Okay, number 8, it's a vertical line. So think about how you write an equation of a vertical line. Notice though that it's a dashed line, and which side is it shaded on? Remember back here in our lesson we said this, And so you can see in the picture that it's shaded to the right. And so you know it's going to be greater than or equal to. So looking at my picture, it's going to be greater than because there's a dashed line. No equal to. My y-intercept, there is none. And my slope is undefined. So how do I write the inequality? So remember how we write the equation of a line that's vertical? X equals a number. And so we have to look at where does it cross the x-axis. It's going to be x is greater than -3. All of these ordered pairs have an x that is greater than -3. So this one is 1, 1. This one over here is 6, -5. All of these ordered pairs have an x that is greater than -3. Okay, number 9, I want you to pause the video and I want you to work through number 9 and then also number 10 and then come back and make sure you did it right. Okay, for number 9, the inequality you should have come up with is y is less than 3x plus 1. Less than because it's shaded below. No equal to because of the dashed line. I can tell that my slope is positive, so that makes sense that it's +3. And I have a y-intercept at 1. Looking at number 10, this one has a negative slope, so I make sure I have a negative slope. It has a y-intercept of 0, so we don't have to write anything right there. It's shaded below, and that's why I have the less than. I have the equal to because of the solid line. And so that's how we write the inequality. This lesson will be continued in part 2.